Reinventing the wheel is no longer just a metaphor for pointless effort. It is an engineering necessity. The traditional pneumatic, air-filled rubber wheel, invented in the 19th century, is fundamentally mismatched with the challenges of the 21st century: climate change, microplastic pollution, urban congestion, and the rise of electric/autonomous vehicles. How new wheel designs solve present-world problems. The microplastic crisis. Traditional tires are one of the largest sources of primary microplastics in our oceans and soil, shedding millions of tons of rubber particles annually. New wheels use biodegradable polymers, 3D printed lattices, or non-abrasive materials to eliminate this pollution. Energy inefficiency and EV range anxiety. Up to 20% of an electric vehicle's energy is lost to rolling resistance and the weight of traditional wheels tires. New lightweight, low-drag designs with integrated motors maximize battery range. Infrastructure decay. Potholes and degraded roads cause blowouts, damage suspensions, and create traffic hazards. Airless, adaptive, or self-healing wheels absorb impacts without the risk of catastrophic deflation. Urban space and congestion. Traditional cars require wide turning radiuses and parallel parking spaces. Omnidirectional wheels allow vehicles to move sideways or spin in place, revolutionizing urban parking and traffic flow. Urban space and congestion. Traditional cars require wide turning radiuses and parallel parking spaces. Omnidirectional wheels allow vehicles to move sideways or spin in place, revolutionizing urban parking and traffic flow. Supply chain vulnerability. Natural rubber is susceptible to climate change and geopolitical supply shocks. New wheels utilize synthetic, lab-grown, or recycled materials, decentralizing production via 3D printing. List of new wheel inventions, real and near future. 1. The BioLattice airless wheel. For example, Michelin Uptis, Bridgestone Air-Free. The design replaces the rubber tire and pressurized air with a 3D printed honeycomb-like structure made from a composite of fiberglass and bioresins. Problem solved. Eliminates punctures and blowouts entirely. It drastically reduces tire waste, no more throwing away worn-out tires, and significantly cuts down on microplastic shedding. The energy harvesting Smart Hub Wheel Hub. The design integrates piezoelectric materials and regenerative electromagnetic systems directly into the wheel rim. As the wheel deforms slightly against the road or brakes, it captures kinetic energy. It also houses IoT sensors for real-time road condition mapping. Problem solved? Recaptures wasted kinetic energy to extend EV range. The embedded sensors can communicate with city infrastructure to alert authorities about black ice or potholes instantly. The shape-shifting, morphing wheel. The design utilizes soft robotics, pneumatic artificial muscles, or nickel-titanium memory alloys. The wheel can physically change its shape, widening and softening for off-road traction or snow, and narrowing and stiffening for high-speed, low-drag highway driving. Problem solved. Eliminates the need for drivers to own multiple sets of tires, e.g. winter versus summer tires, and optimizes vehicle efficiency across wildly varying terrains and weather conditions. The omnidirectional, mecanum/spherical wheel. The design. Instead of a solid rubber cylinder, these wheels feature a series of independent, angled rollers around the circumference, mecanum, or are entirely spherical, held in place by magnetic or mechanical omnidirectional drives, like the spherical motion motors concept. Problem solved. Solves urban congestion and parking scarcity. Vehicles equipped with these can crab walk sideways into tight spots, rotate 360 degrees in place, and navigate crowded pedestrian zones with zero turning radius. The self-healing micro-encapsulated tire. The design. The inner structure of the tire is embedded with millions of microscopic capsules, filled with a liquid sealant and a catalyst. When a nail or debris punctures the wheel, the capsules rupture, the liquid flows into the hole, and hardens instantly upon contact with the air catalyst. Problem solved? Prevents roadside emergencies, reduces the need for heavy spare tires, saving vehicle weight, and extends the total lifespan of the wheel.
The magnetic levitation maglev wheel. The design removes physical contact with the ground entirely. The wheel is a housing for electromagnetic coils that repel against a specially designed track or smart road surface, allowing the vehicle to hover inches above the ground. Problem solved: eradicates rolling resistance, friction, and mechanical wear and tear. It creates near-silent transportation and eliminates tire degradation, making it ideal for high-speed urban transit pods, like scaled-down Hyperloop systems.